Good morning and welcome to my course Basic Physics. This course is generally made for diploma degree students of first year, first semester. Myself, Gopal Chakraborty, Assistant Professor, Department of Physics, Greater Kolkata College of Engineering and Management, JIS Group. You can personally meet me at college premises, ground floor physics lab, or you can also send me a mail regarding your query and doubt to my given mail address, that is godphysics6@gmail.com or gopal.chakraborty_gkcem@jisgroup.org. Students, I have a YouTube channel. The link is given here. So I have already uploaded lots of video as per your syllabus provided by State Council. So you just go through that all videos, and if you feel any doubt, feel free to contact me directly at college premises, or you can also send me a mail. So for this subject, I am your subject teacher. Now the corresponding course pages are www.webscte.org and www.webscte.co.in. And the syllabus for this subject, Basic Physics, is already uploaded in the State Council website. So students, you can easily download the syllabus from the given link. Now the title of this subject is Basic Physics, which is under the category of Basic Science course. It has a credit 3 and 2 lecture per week and 2 practical per week. So this course is generally made for diploma degree students of first year, first semester. So all branches except architecture, photography, multimedia and printing technology. So apart from these 4 departments, rest of the department have to study this basic physics as a part of their curriculum. So as our college, we have only electrical and electronics department. So these 2 departmental students will going to study this course for their first year, first semester curriculum. Now today the topic that I will going to be discuss is numerical problem and solution on buoyancy and Archimedes principle, and this is under unit 2, that is general properties of matter. So prerequisite for these topics are basic mathematical knowledge to solve the numerical problem, and knowledge of basic concepts in science such as physics, and visualization and analytical approach towards the subject that is very much necessary. Now the corresponding course objective is analyze Archimedes principle and buoyancy on the basis of numerical problems and its practical solution. So after completion of this course, students will able to solve numerical on the Archimedes principle and buoyancy. So this will be considered as possible course outcome. Now, before going to start today's topic, I would like to remind you that we have already completed many classes on this theory part of this topic. So, students need to go through that class, and after that it will be very easier for you to understand how you will solve the problem related to buoyancy or Archimedes principle. So those who have missed those video class lectures, please go through that video class lecture once again. And for this today's class, I will like to remind the basic idea of buoyancy and Archimedes principle. So what is buoyancy? Buoyancy or upthrust is an upward force exerted by a fluid that oppose the weight of a partially or fully immersed object. So in a column of fluid, pressure increases with depth as a result of the weight of the overlaying fluid. Thus the pressure at the bottom of the column of fluid is greater than the top of the column. Similarly, the pressure at the bottom of an object submerged in a fluid is greater than at the top of the object. So the pressure difference results in a net upward force on the object. So the magnitude of the force is proportional to the pressure difference, and as explained by Archimedes principle, so is equivalent to the weight of the fluid that would otherwise occupy the submerged volume of the object, therefore displaced fluid. So this is the buoyancy. It means it is basically a upthrust or upward force that exerted by that fluid that opposes the weight of the partially or fully immersed object. So this is the basic concept of buoyancy. And what is Archimedes principle? Archimedes principle says that any object wholly or partially immersed in a fluid is buoyed up by a force equal to the weight of the fluid displaced by the object, with the clarification that for a shrunken object, the volume of displaced fluid is the volume of the object, and for a floating object on a liquid, the weight of the displaced liquid is the weight of the object. So the buoyant force, you can write, that will be equals to the weight of the displaced fluid. So from there you can easily write the apparent immersed weight, that will be equals to the actual weight minus the weight of the displaced fluid. So from there it will be very easier for you to calculate the density, because it means the density divided by density of the fluid, that will be equals to the actual weight by weight of the displaced fluid. So from there you can write the density of the object by density of the fluid, that will be equals to actual weight by weight difference, that means actual weight minus apparent inertial weight. So this is the basic principle of Archimedes, okay, and basic concept of buoyancy, which you need to know to solve the numerical related on this topic. Now I will show you some numerical from your last 5 to 10 years question, so that you need to practice this kind of a numerical. It will be very helpful for you for your semester exam, as well as to understand this chapter in very deep way. Now I will going to discuss these numericals. Now the first problem, it says a concrete slab weight 150 Newton. When it is fully submerged under the sea, its apparent weight is 102 Newton. So that means its apparent weight decreases. Calculate the density of the sea water if the volume of the sea water displaced by the concrete slab is 4800 centimeter cube, considering G is equals to 9.8 Newton per kg. So here G is small g, that is acceleration due to gravity. Now the question is, how we will solve this kind of a problem. Now first you try to find out what is buoyant force. So as we know, buoyant force is the difference between actual weight minus apparent weight of the body, which may be fully immersed or partially immersed. So here it is given that the actual weight of the slab is 150 Newton and the apparent weight is 102 Newton. So buoyant force is equals to actual weight minus apparent weight, that means 150 minus 102, that means 48 Newton. Now according to Archimedes principle, what we know, that buoyant force is equals to weight of sea water displaced. So therefore force equals to mass into acceleration. So mass means density into volume. So here rho v into small g. Now our question is, our objective is to find out the value of this rho. So the force, that value is already calculated, that is 48. We put here the value. Rho is unknown. V volume is 4800 into 10 to the power minus 6 and small g is 9.8. So after calculating, what we get? We get the value of rho is 1020 kg per meter cube. It means the density of sea water which is calculated is 1020 kg per meter cube. Next problem. A fishing boat sails from sea into a river. Now here the diagram is given, that is figure number A and figure number B shows when it is on the sea and on the river respectively. So from figure, compare the buoyant force acting on the boat. Second, the weight of the sea water and the river water displaced by the boat. And last one, the densities of the sea water and river water. Now the solution. How will solve this? First one, for a floating object, the weight of the object is equal to the buoyant force acting on it, since it is the same boat for both cases. Therefore, buoyant force acting on the boat are the same. Since second one, since the buoyant force is equal to the weight of the water displaced, therefore the weight of sea water displaced is equal to the weight of the river water displaced. And last one, the density, as the weight of sea water displaced is equal to the weight of the river water displaced. So that means density of sea water into volume of displaced sea water into acceleration due to gravity that will be equals to the density of river water into volume displaced of the river water into acceleration due to gravity g. So if you equate these two, g small g will cancel out, and what we will get, density of sea water into volume displaced of sea water equals to density of river water into volume displaced of river water. Now since volume of sea water is less than volume of river water, therefore the density of sea water is greater than the density of river water. So the density of sea water is higher than the density of river water. So from here what we understand, that if some body or the particle is floating on the surface of some liquid, so the apparent weight will be same for both cases if we consider two different liquid having different densities. Next problem. It is another interesting and important problem. Here two figure is shows. So figure shows a boat loaded with some goods floating on a sea. The density of sea is water is 1020 per kg cube. Now the question is calculate the weight of the boat. This is the first question, and second question is figure shows the situation of maximum loading of the boat. Calculate the additional weight of the goods that has to be added to the boat to reach this situation. Now how we will solve this? As per our concept, what we know, that weight of the boat is equals to weight of the sea water displaced. So that equals to rho into V into G, where V is the volume of the displaced sea water. So 1020 into the displaced volume, as per figure what we will get, that is 1.5, and small g has a value 9.8. So if you substitute, you get the weight of the boat is equals to 14994 Newton. Now the second question, that is for maximum loading, the weight of the boat plus additional weight, that's equals to weight of the sea water displaced, equals to again rho into volume of the sea water displaced into small g. So here the volume of the sea water displaced, now from the diagram what we will get, that is 4.5. So it is 1020 into 4.5 into 9.8. So it gives us 44982 Newton. Now before loading, the weight of the boat is 14994, and after loading, that is the maximum allowable load, that is 44982 Newton. So therefore we can easily calculate what is the additional weight of the goods that to be added. So that is 44982 minus 14994. That means it is equals to 29,988 Newton. So that is our required maximum load that can be added to the boat. Next question. Here figure is shown. A few balloons which was filled with helium gas are tied to a brick by a string. Explain why when the string is cut the balloon rises. Now as we know the solution that helium has a lower density than the surrounding air which the balloon displaces. When the string is cut, the buoyant force acting on the balloon is now more than the total weight of the balloon. As a result, a net upward force pushes the balloon upward. So, field under physics that is stacked with application of Archimedes principle or examples that solves a problem with solution buoyancy of the object, understanding buoyancy using Archimedes principle. Now the next problem, that is a spherical ball of density rho that's equals to 0.70 kg per L has a radius of r equals to 10 centimeter. If the ball is placed on the surface of the water and released, how much of the ball becomes submerged in the water? Here G is given 10 meter per r square. Now we can use the Archimedes principles to solve this problem, which states that the upward buoyant force on an object is equal to the weight of the fluid and that the object displaces. Therefore, if an object is floating, the upward buoyant force is equal to the weight of the object. So let's begin by calculating that. We are given the radius of the object and told that it is a sphere. So therefore we can use the expression for the volume of the sphere, that is V equals to 4/3 by r cube. Now as per Archimedes principle, so V is equals to 4/3 by 10 centimeter whole cube minus 4000 pi by 3 centimeter cube. So as we know, V is equal to 4000 pi by 3 centimeter cube to 1 L by 1000 centimeter cube minus 4 pi by 3 L. Now multiplying this by the density, we get the mass. So mass is equals to 4 pi by 3 capital L into 0.70 kg per L. That means 2.93 kg. So this is also going to be the mass of the water displaced. We can therefore calculate the volume of the displaced water, that is V equals to m by rho. So as we have calculated that is 0.93 kg per 1.0 kg by L, that means equals to 2.93 L. Next problem, gold whose mass is 193 grams is in kerosene having an upward force of 8000 dynes. If the acceleration due to gravity is 10 meter per second square and the density of the kerosene is 0.8 gram per centimeter cube, then what will be the density of the gold? Now when we try to solve this kind of a problem, first thing what you need to done is you just convert all the given value in a semi unit. So Now weight of the gold in air, that means the weight minus mg minus rho into v into g. So this is the first weight. So weight of the gold, that will be equals to mg, the actual weight, minus the displaced weight. So this is equation 1. Secondly, here the V is the volume of the gold in kerosene. Secondly, the buoyant force, capital FB, equal to the weight of the gold. So if we consider the weight of the kerosene is W dash, so the weight of the gold under this kerosene, that will be W minus W dash, that's equals to rho F into V into G. Now capital V is the volume of the gold in kerosene. So both equations above can be written again as W by W minus W dash is equals to rho B into G into V whole divided by rho F into G into V. W by FA is equals to rho B by rho F. So weight of the gold in air, that is small w, is equals to mg, that is 0.193 into 10, that means 1.93 Newton. So buoyant force, that will be W minus W dash, is equals to 0.08 Newton. Again we substitute the value, that is 1.93 divided by 0.08, that will be equals to rho B by rho F. So from there after calculation, what we will get? We get rho B, that is equals to 19.3 gram per centimeter cube. So that is our objective, that is the density of the gold, that is 19.3 gram per centimeter cube. Next problem. A ship sailing in the sea enters a wide and deep river. The density of the sea water is 1100 kg per meter cube. The density of the river water is 1000 kg per meter cube. Determine and comparison of the volume of the object is in sea water and river water. If the object is floating, then the buoyant force will be equals to the weight. That means density of water into G into volume, that will be equals to density of the object into G into V of the object. So from both sides small g will be cancelled out, and what we will get, that the volume under the immersed water divided by volume of the object will be equals to rho of the object by rho of the water. So the volume immersed, that will be equals to rho object by rho water into volume of the object. So from there the comparison of the volume of the object in a sea water and the river water, that will be equals to rho object by rho sea water into V object is to rho object by rho river water into V object. So from there we substitute all the value, and what we will get, that is 1 by 1100 is to 1 by 1000. So it is 1 by 11 is to 1 by 10. So that means 10 is to 11. So that is our result. These are the possible books that you can refer or consider as your reference book. Now the exam system is same. A student has to appear for 20 marks internal or mid-semester exam. Attendance, assignment, interaction consists of 10 marks, and they have to appear for final end semester exam of 70 marks. So hope all of you have enjoyed and understand today's class. Next class I will also solve problems on another topic which will be very helpful for you. So thank you.